All right, so tonight we're going to be doing stuff similar to 1-4. So 1-5 is all about rational expressions, just like before. But the difference is now we're going to deal with what happens when there's negative exponents. This will be on Friday, the 24th. So your directions are going to be to simplify, just like before. So our first one, a to the negative fourth minus b to the negative 2. So first thing we're going to do is undo the negative exponents, so turn a to the negative 4 into 1 over a to the 4th minus, and then 1 over b squared. At this point, I look at my resulting expression, and it looks like the ones from 1-3, where we just have two fractions being added. So we're going to then find the least common denominator. So our least common denominator here would be a to the 4th b squared. So to make a to the 4th into a to the 4th b squared, I have to multiply top and bottom of this fraction by b squared. To turn b squared into a to the 4th b squared, I have to multiply top and bottom by a to the 4th. So when I multiply the tops, I get b squared on the first one and a to the 4th on the second. After we've got our LCD, we can now add the fractions together. So we'd have b squared minus a to the 4th over a to the 4th b squared. And we can't simplify that any further, so we're done. Okay, so they could potentially get a little bit more difficult, and so we're going to go through 3 more that have various things happen, so that way when you see them on Monday in the problems, you'll know what to do. So our second example, c to the negative 2 minus d to the negative 2 divided by c to the negative 1 plus d to the negative 1. So for this one, we have negative exponents within a rational expression that's a fraction. So for this one of the things we have to remember is we can't, because of this minus and this plus, we can't just move all of this down here. It doesn't work that way. You have to turn each individual term into a fraction. So c to the negative 2 will become 1 over c squared. D to the negative 2 will become 1 over d squared. Over, and then in the denominator we'll get 1 over c plus 1 over d. The only time we can move the entire expression down is if it was in parentheses with a negative on the outside. So because we don't have that, we have to do each one individually. So once we've got the positive exponents, you want to look to see what type of expression you have. So right now we have a complex fraction. So in the first one we only had 2 terms, so we could just add or subtract them. Here we have a rational expression on top and a rational expression on the bottom. So this is where we're going to still find the LCD, but this is where we're going to do something different with it. So looking at our denominators, I need to account for all of them. So I take the highest power, so c squared d squared would be our LCD, the smallest number all of those multiply to, or the smallest term. So this is where we're going to multiply each term by the common denominator, c squared d squared. And we want to remember that it's over 1. So after we do that, let's see, c squareds will cancel, leaving us with a d squared. Here, d squareds will cancel, leaving us with a c squared. And then on the bottom, 1c will cancel, leaving us with cd squared. And over here, 1d will cancel, leaving us with c squared d. Okay, so now we've got it into just one fraction. So now we're going to try to see, can we simplify it? So can we factor something that would allow us to cross cancel or to cancel? So on top, I can make that d plus c, d minus c, because it's difference of squares pattern. On the bottom, I can take out a cd. And when I do that, I'm left with d plus c. So I'll be able to cross out the d plus c, giving me a final answer of d minus c over cd. So when we have negative exponents, these are really the two types that you're going to see. You're going to see some where it's just one term, where you can make the exponents positive and then just follow your getting a common denominator like we did in 1-3. But you can also have negative exponents within a fraction, which means you're going to have a complex fraction, so we're going to follow the process from 1-4. So depending on the type of problem you have with your negative exponents, either of these situations can appear, so you're going to have to be able to know how to tell the difference. Okay, so let's do another one. A to the negative 2 plus b to the negative 1 times a to the negative 2 minus b to the negative 1. Let's move this up. Okay, so when I look at this, I see two ways that we can do it. The first way that we can do this is go about it like we did number 1, where we make this 1 over a squared plus 1 over b, and make this 1 over a squared minus 1 over b, and then get the LCD so that within each one. So add these two together like we did in number 1, and then add these two together like we did in number 1. So our common denominator here would be a squared b. So I'd have to multiply this one by b over b and this one by a squared and a squared. So I get b plus a squared in my first parentheses. And then in the second one, my common denominator is again a squared b. So I'd have to multiply b over b and a squared and a squared. So b and a squared. So that way when I actually combine them, here I'll get b plus a squared over a squared b times b minus a squared over a squared b. So we did each one separately, but in the same process as number 1. So this one, because we're multiplying them together, now you just multiply them straight across. So we'll take the numerators, b plus a squared and b minus a squared, multiply those. On the bottom, a to the 4th, b squared. And then the only thing you might want to do is FOIL those together. So you get b squared minus a to the fourth, just to make it look a little bit nicer and simpler. We can't cancel anything, so it's more just to make it look better. Okay, that's one way to do it, and that way works. I want to show you this other way as well, mainly because if you can notice it, it can go a lot quicker. It's something you might not be comfortable with at the beginning because you've probably never been asked to do it before. So we're going to take the same problem, a to the negative 2 plus b to the negative 1, and a to the negative 2 minus b to the negative 1. Another way to look at this is just another set of two binomials. And in thinking of it that way, we can actually FOIL this together. So if we FOIL this, a to the negative 4 minus a to the negative 2, b to the negative 1, plus a to the negative 2, b to the negative 1, minus b to the negative 2. So just FOILing it together, and in doing that, I can cancel these out because those add up to 0. No matter the fact, even though the exponents are negative, the coefficients, because they're the same variables, will add up to 0, leaving us with this expression. So what we've done by FOILing is we've essentially just combined these two expressions already to be one, like down here. So if we were to now at this point follow the process from number 1, we only have to do it once. So 1 over a to the fourth minus 1 over b squared. Your LCD is a to the fourth b squared So I have to multiply this first fraction by b squared on top and bottom to get it to become our common denominator. On this one, I have to multiply top and bottom by a to the fourth. And so when we combine, now when we add them, or in this case subtract, we get b squared minus a to the fourth over a to the fourth b squared, which is the exact same answer. There are two different ways to think about it. Sometimes this way might actually be the quicker way to do it. So if you can notice something like that, that's great. We'll also get to some later where you might want to do that because the fractions get to be a little much. But you can see you get the same answer, you're just taking care of things in a different order, but the math works the same. So in terms of how you do it right now, your choice. I'm not going to be picky about one way or another, but they are two methods that you do want to know for the future. Okay, so we have one more example I wanted to go through, because this one takes the same idea but now our negative exponent is on an entire expression as opposed to just a letter. So follow the same steps. I'm going to start by moving my negative exponents. So only the x minus 2 has the negative 1 on this first term. So the 2x stays on top, and x minus 2 will move to the bottom. Same thing over here. Only the x minus 2 has the negative exponent. So x squared will stay on top, and x minus 2 squared moves to the bottom. Since I have just two separate fractions being added, we can again do this like number 1. So I'm going to find my LCD, which in this case will be x minus 2 squared, because this has 1x minus 2, this has 2, so I have to account for the larger number. So x minus 2 squared and x minus 2 squared. So on my first one, to get another x minus 2, I have to multiply top and bottom by an x minus 2. So that means my numerator on this first fraction is going to be 2x times x minus 2. In the second one, I don't have to multiply anything because the common denominator is already there. So this is going to stay x squared. So then I'm going to go ahead and distribute the 2x. So I'll have 2x squared minus 4x. And then when I combine them, I'm going to have a minus x squared over my common denominator. And then I'm going to need to simplify by combining any like terms. So 2x squared minus x squared will give me just 1x squared minus 4x over x minus 2 squared. So again, just to make sure, even if you notice it or not, you want to try to factor the top just to see if it's going to cancel. And in this case, when we factor out that GCF of x, we don't have anything that matches. You can leave your answer like this, or you can leave your answer like this. Depending on if it's multiple choice or not, multiple choice will probably give you a factored answer to pick from, so you're going to want to factor it so you can find the matching answer. If it's a free response question, I'll take either one. So as long as it's a free response, I'm not going to be picky about the form if it doesn't end up canceling. But if it is multiple choice, you just want to get it into the form that matches the options so that you can pick the right one. Okay, so if there's any questions that you guys have, make sure you write them down so that way we can go over them on Monday and get all those clarified. All right, have a good weekend.